Hello, this video is for my advanced math students. This is part 2 of example of lesson 70, the exponential growth. We're going to go to page 349 and do the second example. Before I do, I need to point out something. First of all, the book, in the formula, when they have a sub t equals a sub 0 e to the tk, they have kt. It does not matter which of these goes first, whether you have t for time or k for the constant. They're multiplied, so order doesn't matter. You can switch them back and forth. Also, there's a difference in this second problem that will become apparent in a moment. Let's just look right at it. It says the number of bacteria present when the experiment began was 1,200. That tells you that the amount when your time was 0, the amount at the beginning, you haven't started your stopwatch, time is at 0. You started off with 1,200. And again, it's bacteria. Could be anything, rabbits, pizzas, whatever. Then it says after 100 hours, there were 2,700 bacteria. These bacteria are much slower growing. It's every 100 hours, it slightly more than doubles. Okay? If this were 2,400, it'd be real easy. You could say every 100 hours it doubles, like in the last problem. It says, assume exponential growth and find the time required for the number of bacteria to increase to 30,000. In the first lesson, they said, okay, here's a sub 0, here's a sub 9, or a sub 18. How many were there after 24 hours? This problem is reversing the question and saying, not how many are there after 30,000 hours, or how many are there after 200 hours, or whatever. It says, how much time does it take to get 30,000? So what we're going to write up here is a sub t equals 30,000. And this is what we don't know. This is our question. What is that t right there? How much time did it take? So I'm going to rewrite this formula using the number 100. Well, let's just come over here. I've got a sub t equals a sub 0 e to the tk. I'm going to replace t with the number 100. I'm not using this 2,700 first yet. This is what almost always my students just want to skip this one, and I wish you wouldn't. Instead of t, I'm going to put the number 100, and then a sub 0 e to the 100k. Right there. Now I'm going to put in what a sub 100 is. That's 2,700. A sub 0 is 1,200. And I still have e to the 100k. And I want to find this letter k. The first thing I'm going to do there is divide both sides of the equation by 1,200. So 2,700 divided by 1,200 is 2.25. That equals e to the 100k. Just like in our original problem. Just like in the original problem, I'm going to take the natural logarithm of both sides. So I take the natural logarithm of 2.25 and I get 0.8109. I'm going to write it as 0.811. Do not clear this from your calculator. And that will equal 100k. Show that again, the natural logarithm, that 100k jumps to the front, and the natural logarithm of e is just 1. I divide by 100, and I get something in scientific notation on certain calculators. This gives me 8.11 times 10 to the negative 3. You could have that as 0.00811. Either one of those is acceptable. We see 1, 2, 3. Yes. Okay. Now, The question is, how much time did it take to get to 30,000? I've used up too much of my chalkboard. I'm going to erase this. Writing a little too big. A sub t equals 30,000. Well, what I'm going to do is just put that 30,000 in place of this a sub t, and I'm going to write, okay, 30,000 equals the amount at 0 ETK. Well, I know a sub 0, it's, it's 1200. E, this t is what I don't know. That's what I'm going to solve for. And I've got k. I'm going to write it without scientific notation. I'm going to write 0811. Okay. Now, here's one where I've got this letter K really accurate in my calculator. I am going to have to erase that. Just have it pretty significant there on your board, so clear. Because what I have to do here is do 30,000 divided by 1200. That's 300 divided by 12. Some of you might be able to do that in your head. I'm not going to do it. It's 25 equals e to the, let's write this as 0.00811 times time. Right? I'm still trying to get this letter t by itself. I'm going to take the natural logarithm of both sides. The natural logarithm of 25 is 3.21, I'll just say 9 for now. I don't clear it from my calculator. It will equal 0.00811 t, and then the natural logarithm of e is 1. I need to divide both sides by 0.00811. 0.00811. 3.219 divided by 0.00811 equals 396.9, or your time, that's a 9 there, is 397 hours. Slightly different than we did the other one, and you're solving for a different problem. All right, we're just going to go on to the next example. Half-life. We're at the top of page 350. It says the amount of the substance initially present was 400 grams. So my A sub 0 is 400. After 90 hours, only 380 remained. Assume an exponential decrease. In this instance, our numbers are dropping. And determine the half-life of the substance. Make a sketch of the graph. Don't worry about sketching. So they want to know what's called the half-life. We'll get to that in a moment. Let's just find out what our K is. Something I need to tell you beforehand. If your numbers are increasing as they were in the first two, your K will be greater than 0. In other words, your K will be positive. If you have an exponential decay or an exponential decrease, your K will be less than 0, or it's going to be negative. So we're going to come out with a negative number for our letter K. So the amount at any time is equal to the amount at 0 e to the tk. Or in this case, the amount at 90 will be a sub 0 e to the 90k. My amount at 90 is 380. My amount at 0 was 400. E to the 90k. We're going to do 380 divided by 400. And we get 0.95. I guess I should show it. Equals e to the 90k. I take the natural logarithm of both sides. And I get negative 0.0513, we'll call it for now, equals 90k. 90k jumps to the front. Natural logarithm of e is 1. Negative 0.0513 divided by 90. Aren't you glad you have calculators and don't have to use a slide rule? My dad gave me some slide rules. I've been trying to figure out how they work. I can't even figure out how to multiply on those things. All right, and I get negative 5.7 times 10 to the negative 4. That would also be 0.12357, negative 0.00057. Either one of those works. Okay? So, they want to know the half-life. Here's something you may have known from science. The half-life is the amount of time for your initial amount to be cut in half. So basically, they're wanting the amount of time to get this to be 200. If this had been 4,000, this would be 2,000. Okay? Whatever your initial amount was, cut it in half. So a sub t equals 200. I'm going to come over here. 200 equals a sub 0 e to the tk. This is the t I don't know. So 200 equals my initial amount, 400 e to the, what is k? Negative 0.0030057 t. There's the t we're looking for. We're going to take 200 and divide it by 400. That'll give us 0.5 equals e to the negative 0.00057 t. We take the natural logarithm of both sides. We get negative 0.693 equals negative 0.00057 t. By the way, in these problems, whenever you take half-life, because you're always doing half of it and you always get 0.5 here and you always take the natural logarithm of it, it's always negative 0.693 equals your k times your t. So I'm going to divide by negative 0.00057, negative 0.00057 on my calculator divided by 0.00057 equals, and I get a wrong answer. I must check that again. 0.693. I don't think I took the natural logarithm of 5. In fact, I know I didn't because I knew it in my head. Divided by 0.00057 equals, there's a better answer, 1,215.78. 0.79 technically, which 1,216. There you have it. Hard lesson, difficult concept. Let me know if you have questions. Probably I'll put up another video showing more examples. Best of luck. God bless you all. See you later.